Alright, so in this paper, we're going to look at functions or past paper questions, specifically a November paper from 2019. So let's have a look here. We have two graphs that are sketched on our Cartesian plane. F of x is equal to k over x plus q. When we see x on the denominator, that is a hyperbola. So this would be the hyperbola. That looks like a hyperbola. And g of x is equal to x plus 2. So this is a straight line graph which we have over here. So equation of the horizontal asymptote of f. So f has a horizontal and a vertical asymptote. Okay, so the horizontal asymptote y is equal to 1. So it's this here. And we have another asymptote running straight down the middle. Graph G cuts the x-axis at B. So G cuts the x-axis at B, and A and F and G intersect in A and B. So the two graphs meet at this point and this point. So here's my hyperbola going here and then here, and my straight line going there. They meet at these 2 points. B happens to be the x-intercept of both graphs at this point and the point of intersection. Write down the value of Q. So let's go 5.1.1. So the value of Q here is on the hyperbola. It has to do with hyperbola. In the hyperbola specifically, this Q value is the vertical shift or the asymptote. So we can take it straight from the asymptote value here. So we'll just say Q is equal to 1. 5.1.2. So the domain of f is your hyperbola. So it goes this way and that way. It's infinite on our x-axis towards the left and right. So basically we have x is an element of real numbers, but because there's a an asymptote straight down the middle, it does not touch x is equal to 0. So we say that x is not equal to 0. Alright, 5.2.1. Determine the equation of the line of symmetry of f that has a negative gradient. So f is this graph here, a hyperbola. A hyperbola has two lines of symmetry. Alright, the lines of symmetry form an X shape and they meet at the points that your asymptotes meet. So where do our asymptotes meet? There's a vertical asymptote and a horizontal asymptote. They meet over here. So my lines of symmetry would be a line passing through there. Alright, let's just put this through there, and a line passing through there. So that's my two lines of symmetry. Now they are saying the line of symmetry with a negative gradient. So the one going up from left to right has a positive gradient and the one going down has a negative gradient. The equation for the line of symmetry of the positive gradient is x plus q, and this is y is equal to negative x plus q. So if they want the one with the negative gradient, it's gonna be this. So let's go and write that down. 0.2.1, y is equal to negative x plus q. But now this q value, we don't use q. We know what the q value is. It comes from the equation, and we also happen to find it in 5.1.1. So it's not gonna be plus q, it's gonna be plus 1. Alright, 5.2.2, the equation of f. So here's our graph of f. There's the equation. F of x is equal to k over x plus q. Now we know the q value is 1, so let's fill that in. So f of x is equal to k over x plus 1. Now in order to solve this, obviously we stop writing f of x at this point. We can just write y is equal to k over x plus 1. We need a coordinate to sub in for x and y. So that's the way we solve the equation of hyperbola. You've got the asymptote, you need one coordinate. Now on our graph, there are no coordinates. There's no points that are given to us. But what we do notice is that B is the x-intercept of the straight line, and we have the equation of the straight line. And it also is a point on the hyperbola because they intersect at that point. So let's make a note here. So B is the x-intercept of my g of x. So we're gonna let y equal to 0, and the g of x function is x plus 2. So y is equal to x plus 2. So 0 is equal to x plus 2. X is equal to negative 2. So my coordinate for B now is going to be negative 2 and 0. I'm going to then take this and sub it into that equation, that entire coordinate, because B is also on the hyperbola. So I'll say 0 equals k over negative 2 plus 1. So k over negative 2, negative 1 on that side. We can put this over 1 and cross multiply. So k is equal to 2. I'll write my final equation by subbing in k. So f of x is equal to 2 over x plus 1. And that's that. 5.2.3, the coordinates of A. So A is point of intersection of these two graphs. When you want point of intersection, what do? So let's just write 5.2.3. So for intersection, we know one thing. We have to do simultaneous equations. So simultaneous. That means we're going to take our two equations and equal them to each other. So here's one equation, x plus 2, and the other one we just found now. So we'll basically say f of x equals to g of x. The f of x equation is 2 over x plus 1, and the g of x equation is x plus 2. To solve these, we can begin by making them all fractions over 1 and applying LCD. So you can multiply this by x and that by x to make all the denominators x, x and x, x and x. I'll have 2 over x plus x over x, and then I have x squared over x plus 2x over x. Now that all my denominators are the same, I'm basically going to just drop them off. So my equation is now 2 plus x is equal to x squared plus 2x. I can move all of them to the right hand side because x squared is on the right. So plus 2x minus x minus 2. 0 is equal to x squared plus x minus 2. Now I have a trinomial. I can factorize this trinomial as I can factorize this trinomial as x plus 2 x minus 1. Then I can say x plus 2 is equal to 0, x minus 1 is equal to 0, and x is equal to negative 2, or x is equal to 1. Now, if x is negative 2 and 1, why are there two answers? It's because these graphs meet at two places. They meet at A and at B. So what am I going to do with negative 2 and 1? So the one where the B, the value where it meets on the negative x-axis, this is negative 2. And the one where it meets on the positive x-axis, this is 1. So in my coordinate of A, I already know the x coordinate is 1. I just need the y coordinate. Now because A is on both graphs, I can sub it into any graph to find a point. So I'm going to sub it into the easier graph, which is g of x. So basically I'm going to be doing y is equal to x plus 2. That's my equation of the straight line. And then I'm going to sub in y is equal to 1 plus 2. So y is equal to 3. So the coordinates for A are now going to be 1 and 3. Right? And that's the final answer.